Good afternoon. I'm Mark Jensen. This is Physics Behind Fitness. To sum things up from last time, we discussed muscular sequencing and the mathematical formula for each and everyone's tension relationship. As an individual works out, they're really not in control of their sequencing. It's something that they've grown used to and adapted to through a lifetime of habits, lifestyle, genetics, and various impacts to the body. This muscular sequencing is a neurological program which has now become automatic. There is no real way for an individual to change it unless they're trained properly to change it. And in the beginning, before we discuss how to change it, we're going to give you a lot of information regarding why you would even want to change it. Individuals use, in an involuntary manner, their tightest muscles for everything they do. The tightest or the shortest muscles operate all the time, even when you're sleeping, and sequence first when you ask for movement or load or lifting or athletic endeavors. So generally, you're constantly using the surplus muscle and creating a further tension relationship error between the weakest and the strongest. Now, as you strengthen the entire program of your body, you eventually also strengthen the weakest muscle, but it's still weak in relationship to the entire muscle complex or the whole picture of the muscles in the body. So as soon as you reduce your workouts, the first to go is the last to sequence. So whichever muscle is the weakest and has the deficit in tension relationship is going to still be the deficit. It's vital that we analyze this properly and understand its impact to the body. We've discussed a few things and we use the word tension. Are we sure that we know what tension is? We're going to start very simply by defining tension as a pulling force. The development of tension is how the nervous system supports our body, creates movement, and keeps it either safe or in a position for injury. So we want to have the safest tension relationship on our skeleton as possible so that everything we do minimizes joint wear. Excessive tension and excessive adverse tension maximizes joint wear and produces injury or makes a joint prone for injury. A simple thing, and I want to keep that simple so we can understand things, is a suspension bridge. This is a rough drawing of a suspension bridge, partially drawn, of course. Something along the lines of the Golden Gate Bridge. These are cables here, and these are the roadways. The cars would drive over the bridge this way and this way, all day long, hundreds of thousands of pounds. Engineers designed this bridge, and they designed it to last indefinitely as long as the maintenance was performed and the bridge was kept up. So the engineers determined what the value of tension should be for this cable, the next one, and all the subsequent cables on the bridge. Each of these cables would have a different tension, and they would all be engineered correctly to support the bridge to last for as long as possible. If we have a bad guy here, he climbs up this cable and decides to take the tension on this one. He selects a few cables, multiplies them times 10, this one. These are buckles here, so he can come to the buckle and he can crank the buckle and increase the tension. So maybe he picks this one here. Okay, and he cranks the tension on this one, and he cranks the tension 10 times what it should be by design. And maybe it comes down here, right here to this one. We have Z here times 10. So this one, and this one now have tension 10 times the engineered value. When you look at this bridge from the shore, you see no difference in the bridge. However, with an unengineered tension, the support of the spans in which hold the cars and the trucks and other vehicles has been changed. It's altered from engineering. It's adverse tension now that it's unengineered and excessive. As this is loaded with hundreds of thousands of pounds day in and day out, the bridge no longer absorbs the forces correctly. Spans begin to break down, and the bridge destructs itself within a much sooner time than it ever would in the past. This is just an analogy of what is actually happening in the human body. You can see a human body, you could perceive it to look great. People are not aware of their tension relationship. They're not aware of their muscular sequencing. Anyway, the idea in this fixed environment, which is not, or it's static, bridges don't move, and so in the human body it's more complex than this because we incorporate movement that adds to it. But I have to keep it simple in the beginning so that you can understand what kind of devastating effects imbalanced and improper tension relationships are to the human body. We're basically looking at individuals who begin fitness without being instructed properly or analyzed correctly or stabilized first, and in the end of all their work, they will end up with many, many years of pain management. Why are the orthopedic surgeon clients I have waiting for 40 to 80 people per day to walk in their door to discuss why their shoulder, back, knee, elbow, neck, or any other part of their body is aching in their 20s and 30s? It all comes down to the same thing. From the beginning of health and fitness, instruction and the procedure for successfully stabilizing an individual is not being given to the population. We are still asking for children to do exercises which, not on purpose, damage or cause the muscular sequencing to be incorrect. So individuals are destabilized, especially at the lumbar spine and pelvis, when they're in kindergarten. Until the world, and hopefully you, become desirous to understand what it takes to be successful for the long term, that's your entire life. Next, I would like to talk about angular tension and its effect on the body. I'm going to draw a river. This is a river. There's some waves, and know that there's plenty of water in the river. This is a boat in approximately the middle of the river. This boat would like to go up the river and get to where it wants to go. Unfortunately for it, it does not have an engine, but it does have two ropes. This time, we have two individuals that are our friends. Okay, here we sit. We want this boat to go up the river. If these individuals produce tension, a pulling force, in the direction the arrows are depicting towards themselves, equal amounts, each individual pulls away on their rope, creating tension. will this boat move up the river? Okay? The answer is no. And I hope all of you believe that. If our friends move up the river a little bit, now they pull on the rope, same amounts, will the boat move up the river? And the answer is yes. The boat will move up the river until the ropes are 90 degrees again. Okay? So, if the individual moved up here, it would be even more advantageous and get a greater amount of movement. But what we're learning here is that approximately 89 degrees or less, angular force tension can create movement in the direction we desire to go. Okay? In the human body, each muscle has a job. Each muscle should do the job it's designed for. In this case, and this analogy, in our body, these muscles should not be creating the movement. The muscle here should create the movement, and these muscles should keep the boat or the bone in the middle of the river or stabilized. So primary movers have their job. Synergist muscles are neutralizers, stabilizers, or helper muscles, and we should sequence primary movers first to get over inertia. So angular force tension is used all the time to move the skeleton. You can see this in postural analysis, movement analysis, because the way the body moves, and you can perceive its spatial relationship, what its angular force tension is doing. So, angular force tension causes excessive joint wear because it's unengineered and it's adaptive. So, we can practice the wrong muscle and do things. And we can make the wrong muscle do things better to such a point that we end up in some type of a plateau for strength and gains or anything, because once you've used the wrong muscle and it's short, tight, damaged, and injured, it really doesn't do very well anymore. So any force 89 degrees or less, or really 89.9999 degrees, can move a bone or a portion of your body in the direction you desire. If we create 10 units of force and create muscular tension to move this bone, and create this bone to move this way, say, how much units of force do we have moving this bone in this direction? We have 10, this is 45 degrees, 10 units of force and 10 units of force. How much do we have in that direction? That's a good question, and you need a formula to figure it out. Luckily, I've already done that. We're basically at 12.7 units of force in this direction, because the inefficiency of angular force tension causes cumulative tension in the direction that we desire it to be less. Okay, if each of these 10s were this way and this way, clearly we would have 20. 20 is the most common answer whenever I ask this question amongst people that are trying to learn. When you put adverse forces on a joint, connective tissue suffers. Muscle suffers. Bone suffers. Structure as a whole takes the hit. It's important to understand this factor, and we'll move forward from here next time. Thank you very much.